Let's have a look at this example. It says find the value of the pronumeral correct to 1 decimal place. So first thing you should observe is that we have a non-right angle triangle. Non-right angle triangle. I'm sure you're also picking up now in doing senior maths that you really do need to pay attention to seemingly insignificant detail, detail that might not have been all that important to you in the past. Now it is becoming extremely important to pay attention to little things like, well, yep, I can see it's a triangle, but what sort of triangle is it? It's a non-right angle triangle, because the more maths you know, then the more options sometimes you have. And that is certainly the case here. So it's a not right angled, which might automatically get you thinking sine rule, cosine rule. Hopefully it does. And then you start to think, well, I know that I use one given this situation, or the other given a different set of circumstances. So we need to identify what is going on here. So it's pretty obvious. You can see there are two angles and there are two sides, and very nicely it's set up such that this side is opposite this angle and this side is opposite that angle. You just have to be careful should they give you a situation that looks like two angles, two sides, and it is, and you do actually end up using the sine rule. However, the sides and the angles are not opposite one another. I'm sure you'll come across some situations like that as you work through the textbook, and, you know, really be aware of that and think about your other options there. And that's all I'll say about that, and hopefully you will work your way through that question. It'll be different, but it's not impossible, and it is a matter of you making connections to things that you know. It won't involve any new trigonometry that you've never been exposed to. It will require you to recall just some basic properties that you know about triangles, in fact. Okay, but let's keep going with this one. So I can see I've got two sides, two angles. I know it's going to be the sine rule. I'm going to write my sine rule. A on sine A is B on sine B. And if you've got a thing that you'd rather use A's and C's or B's and C's, then please do that. So what we would do now is, well, they've actually used the letter A, lowercase a, which is fine, which means I would call this angle over here A, and that will be all really good. Then my other side becomes B, and the angle opposite is capital B. So I sub into the formula, and we've got the sine of 105.31, and B is 6.1 on the sine 35.49. Now, as you can see, we've got values for 3 out of the 4 places, and we've just got one unknown. It's an equation. I think most of us would say we would get that A by itself by multiplying both sides by sine of 105. 31, is it? Sine 105, 31 minutes, and just go straight to the calculator to do the calculation. And doing that calculation, just put this down, I'm getting 10.04, hopefully I haven't made a mistake, which rounded to 1 decimal place is the instruction, gives me 10.0 units. In this next example, again, note that we've got a non-right angle triangle, and an additional thing that you really need to note is that this theta is obtuse. that's going to be a problem if it involves sine, because remember, your calculator won't give you the obtuse angle, and we will be required to recall and use that sine of 180 minus theta, and that will give us, this will be your obtuse angle, is the same as the sine of theta. So the calculator will give me the acute angle, and I will need to do 180 minus it in order to get the obtuse angle. So this is another question that highly relies on your ability to note the detail of the question. Noting detail. I'm sure there's been many times when you've jumped into questions and in triangles, you've gone ahead and you've got them all correct, and you've never really needed to consider whether your angle was obtuse, acute, or whatever. And because you got the right answer, you just moved on. Can't afford to do that now because we've learnt more maths. You're exposed to different situations, and it is really important that you are noting every little detail. So it's looking like two sides, two angles, and yes, when we look more closely, that is the case. The 4.9 is opposite this unknown, and the 3.7 is opposite that angle. So this time, obviously, we're finding an angle. We still write our formula, and I just stick with A's and B's. Doesn't really matter which I let this theta be. I'll just stay with A. Then this side becomes lowercase b, and obviously this angle. So I've got 4.9 on the sine of theta, there's my unknown, is equal to 3.7 on the sine 21 degrees, 31 minutes. Now, no problem with any of those calculations. So I'm not sure, any of those values. We've got three values and one unknown, perfect, in an equation. To solve this, maybe for many of you, you would cross multiply and you'll get your 3.7 sine theta is 4.9 sine 21, 31. And then say, well, actually, I want the sine theta by itself, so we're dividing by 3.7, and then we know that we need to get theta, we need to take the sine inverse. And again, we're going to use the new calculator, and this is hopefully where it really does save us from making some mistakes, in that we shouldn't make an error with this fraction. And so the calculator won't either give us the wrong answer or give us an error message. So you can see I've put that calculation, and I think I might have got it wrong, into the calculator, and the calculator is showing me 29.05. Answer to the degrees and minutes, so we need to go second function DMS. Really not second function DMS, just straight out DMS. And we've got 29 degrees, 3 minutes, 35.92 seconds. Now we know that any time that either these minutes or seconds go over 30, we're to round up. So we've got 29 degrees, 4 minutes. 29 degrees, 4 minutes. Now, hopefully, having made this observation back in the beginning, we're not happy to leave our answer as 29 degrees, because that is not a number between 90 and 180. So we write something like, but this is not obtuse. Therefore, theta is 180 minus 29 degrees 4 minutes. You can see that that's 150 degrees 56 minutes, the seconds. less than 30. So we've got 150, 56. And there's your answer, theta. I haven't actually included an example with the cosine rule, but I think you shouldn't have any trouble, maybe only in the actual calculations. You won't have a problem. The calculator understands if the angle you're finding is obtuse. That's not a problem when you're using inverse cos. The calculator gives you the obtuse sized angle, so you don't have to actually make this adjustment that we did with the sine rule. So that should be all good. I will finish the video here, and you could get started on some of the questions from H&I, or you can listen to the very next video on the area of a triangle, and then just work through all of the examples in one go.